Okay everyone, so here we have first principles. It's basically a section of work under derivatives. So when looking at first principles, we must know that this f of x is the given, and then this one is what we determine. We determine this one. So how do we do this? So like I said, we determine it. So that means we already have the f of x in the formula. We must now determine the fx plus h, and we do that by writing like this: fx plus h equals 3x plus h minus 2. Then we must times out the brackets: 3x plus 3h minus 2. This is fx plus h. So now what we do is we must write this, but if we substitute into the formula, and we do that by f first derivative x limit h tends to 0, then we write 3x plus 3h minus 2 minus. Very important note to make: when you write this minus, basically this minus, we put in brackets anything that comes after, and you will see why. Okay, very important also, when you're writing the limit, you continue writing the limit until you cancelled everything out and substitute everything out. Then you write the limit, then you can stop writing the limit. So what are we left with? We must now basically get these brackets away, so we multiply the negative e. That's why we keep in the brackets. Plus h, not plus h, over h. H tends to 0. So what's very cool with this is almost always whatever you have here at the back will cancel with something in the front. That's how you know you're on the right track almost. So what are we left with? We are left with 3h over h. Then this h cancels with that h. Then we are left with 3. Now to check this, we do the first derivative of this equation. If you can remember, anything or a constant that's standing alone becomes 0. It becomes, we don't write it, okay, it becomes 0. 3x, so this is a 1 here on top. We all know that there's a 1 on top there. So this 1 multiplied with 3 gives us 3. And then 1 minus this exponent 1 will give us 0. So it's x to the power of 0. And x to the power of 0 is 1. That means it's 3 times 1 plus 0 equals 3. That is doing the derivative straightforward from here. First principles is just a method of differentiation. We now know that method of saying of saying of saying this x n minus 1. You can use this method to check this answer, and it must be the same, because first principles is just a method of differentiation. But when they ask for first principles, you do this method with the limits. You don't do this one. If you do this one, you will get maybe one answer, one tick, one mark for the answer, but the method will be wrong. So you will lose like 34 marks maybe. Who knows how long it will be. But this is just to check. Only to check. Only to check. That's one over here. Only to check. Very important. Okay. The next one. The next one. Already we have this f of x. So we must get the fx plus h. So fx plus h equals minus 4x plus h squared equals minus 4x plus h x plus h equals minus 4x squared plus xh plus xh plus h squared equals minus 4x squared. This is 2xh. When you add these together, 2xh times minus 4 is minus 8xh minus 4h squared. This is fx plus h. So to continue, we must now substitute this fx plus h and this fx into our formula. So we start by f equals limit h tends to 0 minus 4x squared minus 8xh minus 4h squared minus 4x squared over h. Always remember to keep this minus in and the brackets. Very important. So always write the limit. You write the limit until you cancel everything, or you substitute a 0 into x into h, because h is 0, but we'll get to that. So what do we do now? We write minus 4x squared minus 8xh minus 4h squared plus 4x squared over h. And again, like I told you, one back one will cancel with one front one. It's almost always like that. So again, limit h tends to 0, and now what we're left with is a minus 8xh and a minus 4h squared. So what we're going to do now is we're going to factorize out a minus 4h. Then we're left with a 2h, no, a 2x here, a 2x and here is an h minus h over h equals minus 4. See, because this h and that h will cancel, so we're left with 2x minus h equals minus 8x plus 4h. So what we do now, limit again. We stop writing the limit when we substitute now. So because we can't go any further than this, what we do now is we substitute this 0 from the limit into h, so that we have minus 8x plus 4 times 0, and then this will give us minus 8x as an answer. Minus 8x as an answer. And also we can prove this by doing the derivative of our given. So minus 4x squared equals 2 times minus 4 is minus 8x. 2 minus 1 is 1 equals minus 8x. That's our answer. Again, this is just to check. To check only. When they ask for first principles, we do first principles only. This is only to check. Only to check your answer. Okay. Next one. The next one is negative 2x plus 1. And we know by now that that's the given formula. That's the given f of x, so we must determine fx plus h, and we do that by substituting x plus h into x plus 1 equal, so multiply out 2x minus 2h plus 1. Then we do h tends to 0. Then we write minus 2x minus 2h plus 1. That minus bracket minus 2x plus 1h. So let me see this one. So limit, oh, copy is dying. So the limit h tends to 0, minus 2x minus 2h plus 1 plus 2x minus 1 over h equals limit h tends to 0. So good note to make. Again, this back one cancels with this front 2 minus 2x. This minus 1 cancels with that one there. Then we are left with minus 2h over h. Again, this h cancels with that h, and we are left with 2. So to check our answer, we take the given, this constant is a 1 and a standing alone, so we know it becomes a 0. There's a 1 there. 1 times minus 2 is minus 2. This minus 1, it's a 0. X to the power 0 is 1. The answer, it's minus 2. Oh yes, it is a minus 2. I didn't get the sign, but the answer is minus 2, yes. You see, that's why it's important to check the answer. But this method, it's only to check the answer. Method to check first the response source only. Only. You only use it to check, you don't use it to actually do an equation. Okay. The next one. Hopefully my pen will last me this one at least. Okay. We already know that we already have this one. We must determine fx plus h. Always to be like this. So we have 5x plus h squared equals 5x plus h, x plus h equals 5x squared plus 2xh plus h squared equals 5x squared plus 10xh plus 5h squared. Okay. So now, what do? We write as follows. We write f1 of x equals the limit h tends to 0, 5x squared plus 10xh plus 5h squared, that minus 5x squared over h. I hope everyone can see this because I know the pen is dying. So the limit h tends to 0. So let's just speed this a bit up. So we know that this minus 5x squared is going to cancel out this 5x squared. And we are now going to have to factorize out. We're going to have to factorize out a 5h. A 5h. So we are at 5h, and we have 2x there, plus h there. Then plus h cancel that h. So limit h tends to 0. You are left with 2x plus h equals h tends to 0. Oh, I don't think this pen is gonna make it. So we're left with 10x plus 5h. But this will become 0. Wherever h is, it's 0 because it's 5 times 0, because h tends to 0 here. So we do 10x plus 5 and 0 equals 10x. Okay, so again, to check this, we take our given 5x squared, or we take our given 5x squared, then we say 2 times 5 is 10x 2 minus 1, it's 1. So the answer is 10x. Answer is 10x. Okay. First principles, it's very nice. Let me do two more. Let me do with a red pen now. So okay, five. Number 5 now. So for this one we have f of x is equal to minus x squared minus x squared. So we know by now we must determine the fx plus h. And we do that by substituting x plus h into x. So we say x plus h squared. X plus h, x plus h. So minus x squared plus 2xh plus h squared equals minus x squared minus 2xh minus h squared. All you must do is simplify this, or basically multiply it out like this. You can't do anything if it's in the bracket still. You don't want to remove all the brackets, everything. So we can now h into 0. So we write it x squared minus 2xh minus h squared. That minus the bracket. Very important, that bracket. Very important. Okay. Limit h tends to 0. So you can see already that this will become positive x squared and it's negative, so these two cancel each other. And again we're going to have to factorize out an h. Let's factorize out a minus h. So minus h, and we're left with 2x minus h plus h over h. So we can see already that that will cancel that one. I hope you can see that this is the same steps all the time. So no matter what you get, and then minus 2x minus h equals minus 2x minus 0 equals minus 2x. There you go. This is always going to be like this. Same steps all the time. So first it is determining, first step is to determine fx plus h. Second step is to substitute and brackets and brackets. Third one is to factorize h. Then we simplify this. We're gonna say simplify. Okay, yes, let's say simplify. I say simplify because we must now multiply this out again. That is simplifying, and then substituting 0 for h. And that's our answer. You can follow these steps, you will always get your answer if you follow these steps. And multiplying this out properly, very important, because you need this whole, you need this whole, you need the whole equation there. Okay, one more. So this last one is number 6, and it is saying fx equals 4. Again, if you can remember, it's alone. The constant is alone. There's no x value, there's nothing. So, what do? We can't do anything. But let us just see in theory what it would be. So, this is x to the power of 0. Let's determine fx plus h. Fx plus h equals 4. Then this here would be x plus h to the power of 0. So, how do we do this? So what we do is, same steps. H into 0. So it is first fx plus h minus 4 over h. And then limit h tends to 0. This here is going to be a straight 0. But let's continue and say, okay, this is 0 over h. Then it's 0 over 0. This is when we substitute in 0 here. But here already we have our answer. It's a straight 0. I wanted to show you this because I want you to see why the constant, when the constant is alone, it's 0. Always. You can see here why. Because this is giving you 0. You can't, there isn't an x over h to simplify or to multiply or factorize with, like over here and the other questions. This is just a straight 0 from here already. From here it's 0. I just hope you can see that, because it is just the way it works. Okay, this is first principles and differentiation. If you follow these steps, you will not go wrong. You will not go wrong. Okay.